everyone, this is Mrs. Finney recording our lesson notes for lesson 5-4. This is from our concept 14, writing and simplifying expressions. And we are on page 288 in our workbook today. So please get to page 288. As promised, you're going to get a chance, an opportunity to see more of the distributive property. I said yesterday we'd see more of it today, and here it is for us. Okay, so we've got our distributive property. You can see an example reminder here of our key concept with that distributive property. And notice here it draws out and shows you, yesterday I talked about identifying that -7 as the number that would be bombing the fort or dropping in on every piece. And so let's look at some examples and review that distributive property. Okay, so one more kind of example here, just as a review from yesterday before we look at some of our word problem examples. When we look at finding the distributive property, if I have a number in front of the parentheses and I have a bunch of stuff inside the parentheses, like let's say I have 1b plus 6 on the inside, the -2 is my bomb, and it goes inside and multiplies and attacks every piece inside the parentheses. And so -2 times 1 is -2b. And I have a plus sign. The plus carries. We keep the math that's inside the parentheses. And -2 times 6 is -12. So we could write and think about this expanded expression as -2b plus -12. Or we can use our prior knowledge and use the change to recognize that plus a negative is the same as -12. Okay. Be sure to stop the video and fill in your notes as you go. So step number 2, how does the subtraction part change when this expression a times b minus c is expanded? So here we see an example where we can use the distributive property even if there's no numbers whatsoever. So I'm going to rewrite this a little bit bigger so that we can see how it works. A times b minus c. A is my bomb, and it's okay that it's not a number. We still do the math the same. We're still going to take the thing outside and multiply in. And so we'll end up with A times B minus, the minus stays the same, A times C. Okay. We can do the same thing with an addition example. If I have A times B plus C, I can take the A on the outside and multiply it in. A times B plus A times C. All right, let's look over on the right-hand side at some examples with numbers. So here we have number 4 on page 288. Shoes and hats are on sale. The expression 1/4 times S plus 2480 can be used to determine the discount. Write another expression that can be used to determine the discount. So if I have 1/4 times the quantity S plus 2480, 1/4 I can write as 0.25. If we take 1 divided by 4, we can convert it into a fraction. And because we have that number outside the parentheses, even though it's a decimal, the distributive property works the same way. We're going to multiply it into each piece. And so we end up with 0.25s plus 0.25 times 2480. And we can use our calculator to do that decimal math. 0.25 times 24.8 gives me 6.2 as my constant. And this is our final answer because we don't know how many shoes we're buying yet. All right, let's look at one where the BOM is a letter instead of a number. So in this example number 5 on page 288, X is my BOM. Ooh, that's kind of small. I'm going to rewrite it bigger. X times 4 minus 3.4y. So my BOM is the X. That's what's going to get multiplied into each piece. And so we're going to have X times 4. I can't actually multiply and get a number because I don't know what X is, but I still have the X times 4, just like when I multiply a number in, I'm multiplying in. The minus sign stays the same, and then I end up with X times 3.4y. And so at the very basic level, this would be a correct way to bomb the fort. Now, normally we would rewrite this and we would put the 4 first. So we have 4x minus, and again, we put the number first. It's just kind of our standard for how we'd want to write it. And so we can rearrange so that the numbers are first, makes it look a little bit neater. If we think about our lesson from yesterday when we were combining like terms, be careful here. A lot of people will want to go one step further and do the subtraction because they both have an X. But remember our definition of like terms, the variables have to be identical in order for them to be combined. So this first term has just an X, and our second term has an X and a Y. Because they're not identical, we can't combine them any further. Okay, let's look at an example that has a few extra pieces to it here. So here we have negative 2/10. If I divide that, I know that negative 2/10 is the same as negative 0.2. And so if you prefer, you can turn it into a decimal right away. Now, some of you might see a different step that you could do first. If you do a simplification step first, that's okay. I'm going to follow the steps that we've been practicing together for consistency. So my BOM is negative 0.2, and I'm going to multiply that in by every single piece. So negative 0.2 times 1 is negative 0.2 minus, and now here, negative 0.2 times 2, if we multiply that, negative 0.2 times 2 is negative 0.4. Notice what happens here. We end up with minus a negative. We'll simplify that in a minute. But I keep the minus sign and I bring in the negative. Plus, negative 0.2 times 2 is going to be negative 0.4 again. So first step, we identified our BOM and we multiplied it in to every single piece. Now we're going to do some more simplifying. Here I have a negative 0.2 and a negative 0.4. Those are both just numbers, which means I can use our skill from yesterday to combine them. Negative 0.2 and negative 0.4, if we put that in our calculator, negative 0.2 plus negative 0.4, we get negative 0.6. And the last little piece that we're going to simplify to make it a little nicer is we're going to use the change, and instead of minusing a negative, we're going to turn it into addition, because a negative times a negative becomes positive, and the change says that we can change subtraction to adding the opposite. So instead of minus a negative, we can add a positive. And this now is as simple as we can go, because the second term has an X, the first term is just a number. They're not like terms, which means we can't combine them further. Thanks for tuning in and taking these notes to help you master the distributive property.